All right, so now we're going to talk about the final type of research method, which is the experiment. You've learned about case studies, you've learned about surveys, you've learned about naturalistic observation, you've learned about the importance of getting a representative sample to match your population, which is also super important in an experiment, okay? So an experiment is a research method in which an investigator manipulates one or more factors. We call what the researcher manipulates an independent variable. We're going to go into more detail in that in a second. And the researcher does this in order to observe the effect on some behavior or mental process, okay? So the change in behavior in the person being experimented on is the dependent variable. If this, then this, okay? If this is the independent variable, so think of I and independent and if, and the dependent is what you're actually measuring, that change in behavior. All right, so some things about experiments. There's a lot of pros, but there's also some cons, okay? The pros are that the researcher has total control over the environment, right? In the naturalistic observation or the survey or even the case study, the researcher has very little control. They're actually doing a lot more observation. Here, the experimenter can kind of get down and dirty. They can control the environment and they can elicit certain responses from the people who they're researching. And it does, if done correctly, and we'll talk about this later, removes research bias. Okay, it's very possible if you're doing a naturalistic observation, we're all human. You might only see what you want to see. However, when an experiment is done correctly, it removes that bias, okay? And probably the most major setback or a con of the experimental method is that people know they're being experimented on and they might change their behavior, okay? So an example of that is you guys are probably just learning to drive or newly driving. You know that you drive differently when there's a police officer behind you, right? It's probably safe, it's probably a good decision, but we know we act differently when people are watching us. And I had to quickly just fix that typo right there. This idea that we change our behavior when people are watching us is called the Hawthorne effect, and something to definitely watch about in a psych experiment, and to observe yourself. When do you act differently when you know that people are watching you? All right, so in order to kind of walk us through this, I've made up an experiment in my head that we are just going to be talking about, okay? So in an experiment, you need to gather a group of people or animals, but let's go with people here just because it's more relatable, okay? And you would gather, let's say 50 people for your experiment, okay? You're gonna put half of those people in your experimental or treatment group and half of those people in your control group, okay? The experimental group are the folks that are getting manipulated by the researcher, while the control group is not getting manipulated by the researcher, and we're comparing the behavior of the two groups. Let's say, for example, you have a cancer drug, right? You need to know, does this cancer drug work? Okay, so you would take your 50 participants, and no, I'm just using 50 as an example. Half of those cancer patients are going to receive my drug that I've created because I want to see if it works, okay? But I need a baseline to control or to compare that group to, and that would be my control group. And that group would not get the cancer drug. They would get a sugar pill or some kind of other placebo, okay? But let's keep it simple for now. Here's my research question. Here's the thing I want to know about. What I want to know about, does drinking caffeine, help you on a recall test later? Okay, so in this case, or memory, let's say in this case, my experimental group are my 25 folks who I'm going to be giving a caffeinated beverage to, where my control group is going to be given a beverage that does not have caffeine in it, okay? So that's the experiment. That's what we're going to kind of roll with for the sake of this video. I, as a researcher, am testing caffeine's impact on memory, okay? Half my group is going to be drinking coffee and taking a memory test. Half of my group is going to be drinking water and taking a memory test. And as a researcher, I want to know, do my folks who are drinking the coffee, do they do better, worse, or the same on this memory test, okay? When you are doing an experiment, you want to randomly assign your participants to the control or the experimental group. You don't want to confuse random assignment with random selection. Random selection is how you pick people, right? We talked about the example of Carondelet and De La Salle students, and I'm surveying them on their feelings about online learning. I randomly selected them from an email list, okay? Once I have randomly selected them, then I'm going to randomly assign them, okay? So in this case, I'm randomly assigning my 50 people into the coffee drinking group or the water drinking group. All right, so here's my research question. Does drinking caffeine while studying increase memory? Okay, so my experimental group or treatment group, I'm going to give them all a Starbucks iced coffee, and then I'm going to, while they're drinking it, ask them to study for a standardized memory test. Okay, my control group is going to get a LaCroix because why not? And they are also going to do the same studying for the same a memory test. And note, I've tried to make the drinks comparable, okay? I've created them, I've made them both cold. They might both be something that are appealing to people, but the thing I'm really trying to measure is not did they like their drink more, is does the impact of the caffeine on that Starbucks drink impact them in a positive way compared to my folks just drinking LaCroix. Okay, so the independent variable and the dependent variable. This is really important. If this feels overwhelming, I totally get it. There is a lot to learn here, okay? The independent variable of my study is the variable that I'm controlling as the researcher. So in this case, I am controlling the caffeine intake of my participants, okay? So in this case, the independent variable is caffeine. The dependent variable is what I'm trying to measure, and that is going to be the outcome of the memory test that they take at the end of my experiment, okay? So independent variables and dependent variables are an if-then statement. If my subjects drink caffeine, will they perform better on a memory test, okay? Hopefully you've read that in the book. We're gonna, of course, do some practice in class. Okay. Also, sometimes, to go back to the example of the cancer drug, sometimes there's not a LaCroix equivalent that you can give to your other participants. And sometimes a researcher will give half their group, their control group, the group that's not getting the experimental treatment, some kind of placebo. And a placebo is typically a pill with no known side effects. So you're basically observing the two groups. One is straight up getting the drug, one is not. And you want to just make sure that it's actually the drug that's working and not people's minds. Because there's times when just because people believe they're taking a pill to help them with something, it actually does help them because the mind is super complicated, right? An example, okay, it's kind of, I'm going off the rails here, but I hope that it kind of serves the purpose, okay? Let's say I'm hosting a party for people who are over 21 years old, okay? Legal drinking age. I hand half of them alcohol as they walk in and half of them some kind of regular water drink, but I've convinced them that it's alcohol, okay? As the researcher, I want to know, does the alcohol impact behavior? Or does just the thinking you're drinking alcohol impact the behavior? So if down the road, 3 hours into the party, half of my people are stone sober and half of mine are drunk, I know it was the alcohol that impacted people's behavior. But what if 3 hours into the party, the people who drank the water are acting drunk because they thought in their head they were drinking alcohol? So the mind is super powerful. So you want to make sure if you're researching a drug, that the drug itself is actually working on your participants, not people's minds who feel like, hey, I'm getting this new treatment and for whatever reason, it sort of helps them feel better, okay? Think about a little kid who's crying, they didn't cut themselves, but they want a Band-Aid, and then the Band-Aid, like it's magically feels better for them, right? The Band-Aid didn't do anything. Whatever is doing something for that kid is happening in their head. So that's really the placebo effect. It's the idea that something helps you just because in your mind you believe it does. Okay, something else to know. A single blind experiment is when participants do not know if they are in the control group or the experimental group. Okay, so let's say let's go back to the coffee test, right? I wouldn't tell my control group or my experimental group maybe necessarily what I'm studying. I'm just saying, hey, I'm studying memory, right? Which is only half true because I'm really studying caffeine's impact on memory. But I don't want my people drinking LaCroix to kind of know like, oh, maybe I won't score as good. So you want to keep people in the dark sometimes on exactly what you're doing. And we'll talk about the ethics of that later because you don't want their minds to impact the outcome. Okay, so same thing, if I'm researching a cancer drug, my control group is getting a placebo and my experimental group is getting my actual cancer drug, but I'm not going to tell my control group or my experimental group what pill they're getting because I want to like decrease any of the other confounding variables of this experiment. I just want to study the drug. And if I tell people what drug they're getting, that might impact my results. Okay. So if I tell my coffee group, hey, I think you're going to do better on this memory test, that might actually impact the outcome. So I do not want to tell my participants if they're in the control group or if they're in the experimental group. So when you don't tell your subjects, your research subjects, which group they're in, that's a single blind study. The researcher knows, but the participants do not. Now, there's also this thing called the double blind experiment, and that's when neither the patients nor the doctor knows. So there is some other research group outside of these people who are actually running the experiment and keeping tabs on what's going on. So let's go with the cancer treatment, for instance. In a single blind, there we go. Of course, this is not going to be, okay, there we go. In a single blind, I, the doctor, give the placebo to half and the cancer drug to half, okay? And I know who has what. But maybe me as the researcher, that's going to make me a little biased because I'm going to look to the experimental group to actually be doing better, maybe more so than they actually are. A double blind removes bias even more. So you'd have some other person come in and give the drugs, and then you would not tell the doctor or the researcher which people have which drugs. That way the doctor is a bit less biased as he's observing the impact of this cancer drug on the people taking it. Okay, so single blind is when the participants don't know which group they're in. Double blind, even better in some cases, is when neither the participants or the doctor knows. And that's going to really help the doctor or the experimenter observe a little bit more objectively with a little bit less bias on what impact certain things are having on people. Okay. Let's try to let some of that sink in. I know that it's a lot, but this is like ultra important in the AP Psych classes, understanding how experiments work, okay? Sometimes you might end up with a confounding variable in your experiment, okay? So a confounding variable is a factor other than the independent variable, so not the thing you're trying to control, that might produce an effect in the experiment. Okay, so part of that could be research bias. Okay, let's say with the coffee example, I am biased when I look at their memory test results because I want the caffeine group to do better. Or let's say it's a single blind study with the cancer drug and I, the doctor, know who has what. And I might say, oh, look, the people with the cancer drug, they really did better because that's what I want to believe as the doctor because I really want my drug to work. Okay. Another thing might be like a lurking variable, kind of back to when we talked about the sunburn and the ice cream sales. Okay, there's something else that we're not accounting for when we look at our results. So let's say in the coffee case, let's say I gave my experimental group, we gave them caffeine. Some of them had just, let's say, iced coffee, no milk, no sugar, no nothing. Whereas a couple of other people in my group, let's say they ordered frappuccinos. Well, the difference between a frappuccino and an iced coffee is the amount of sugar in that drink. So maybe It's not just caffeine that impacts memory, but also sugar. So when you're designing your experiment, you want the least number of confounding variables as possible. Some you can control for, like bias, right? That's why we have the single and double blind study. The lurking variable is a bit harder, and it requires a lot of forethought before you do the experiment, so that I know if I give half my group LaCroix and half my group Frappuccinos, am I studying the impact of the caffeine, or am I studying the impact of the sugar, or both? So we really want to narrow it down to one thing. So I'd want to give all my control group the cold LaCroix. I'd want to give all of my experimental group the cold iced coffee with nothing else in it, because I just want to study the caffeine, okay? All of these things, any sort of confounding variable impacts the validity, and that is how legit your results are, okay? So the more control that you have, the less confounding variables, the more likely your study or your experiment or your survey or whatever is likely to be considered valid in a scientific community. And that's really the goal. All right, so when you guys pop on the class here in a little bit, we are going to check for understanding by actually creating our own experiments, okay? So probably the four most important things to know right now: control group, experimental group, independent variable, dependent variable. So go ahead and look over that and hop onto Zoom when it's time. Thanks, guys.